Good evening, peeps. Something came up and it's going to take up a fair bit of my time, but it's been a while, isn't it? So now a quick swing and then a quick look at a couple of things. Come on. It's a Nerf gun bullet. Because it's only fake lawn, I'm not growing grass in here. Defy podcast. Stay on there. It's not real grass, like I'm not growing a little square of grass. So what's going to happen, I'll take the swing when a car comes or a truck or something. I'll shut the doors, go out, shut the door, go and just do something or whatever. If I hear something go off, I'll act accordingly. If anybody else comes in, stay quiet, don't move, don't say anything. You're here for the science, not for the golf, okay? And then I'll come back and we'll just go over a couple of little things. All right? All right. It's a shame I can't practice because, oh, there's a car coming. Oh. No, there isn't. She had the window fixed. What are the chances? Same window. Come on, noise. So, we're going to go straight to the doubles. Not loud enough. Just listen to this. Right? With the old double slit. Plenty of trucks come up and down. I have to wait for a truck.
You've probably heard of the double slit experiment, right? For centuries, it's been the cornerstone of quantum physics.
Centuries.
A mind-bending demonstration of how light and even particles can act like waves. But what if that understanding is incomplete?
Huh?
A new theory is shaking up everything we thought we knew about light, interference, and the very nature of quantum reality. Today, you'll discover the revolutionary idea of dark photons. The double slit experiment has always been a fascinating mystery.
The normal photons are invisible and massless, but these dark photons, you're going for that one now, the dark photons.
Shine light through two narrow slits and boom. A pattern of interference appears, as if the light somehow passes through both slits at once. Even sending one photon at a time creates that same wave-like pattern. How?
One photon at a time. They're sending one photon at a time. How?
For decades, the answer was simple. They behave like waves until we measure them. But now, a bold proposal from physicists at the Max Planck Institute, in collaboration with ETH Zurich and Brazil's Federal University of São Carlos, suggests something even more radical. Maybe waves aren't needed at all. They've introduced a new model called the dark photon interpretation. According to this theory, the interference...
They've introduced a new pattern. Did you hear that? I mean...
Even more radical. Maybe waves aren't needed at all. They've introduced a new model called the dark photon interpretation. According to this...
New model. It's all hypothetical, theoretical. But you guys love it, yeah? Because that'll be it. That's what it is. I wonder if the dark photons, what if they run faster than the normal photons? What do you reckon? I'd say they're good. But we'll never know, will we? All of this, right, everything that you're hearing about photons, but the sun is directly behind the moon during a solar eclipse. See how it works? What does that say to photons? If you've got common sense, right?
Theory, the interference pattern doesn't come from overlapping waves, but from interactions between two quantum states of light. Bright photons, which we can detect, and dark photons, which exist but remain hidden from our instruments. When a photon encounters the slits, it doesn't split spatially like a classical wave. Instead, it enters a superposition of visible and invisible states. What we see is actually the result of a kind of quantum conversation between the detectable and the undetectable. In traditional quantum theory, measuring which slit a photon goes through collapses its wave function, destroying the interference. But in this new view, it's not about destroying anything. It's about shifting the photon's state from visible to invisible. Measurement doesn't alter the path. It alters the coupling with the environment. This idea ties into experiments like the quantum eraser, which show that how we choose to measure changes what we see, even after the fact. Under the dark photon model, the pattern was always there. What changes is whether we make it visible. Those dark regions on the screen where we see no light, they might not be empty at all. They could be filled with dark photon states.
No.
Invisible but real, like hidden rooms in a house we thought we knew. Maybe we've just never had the right kind of flashlight. The implications are massive.
Oh, shut up.
If these hidden states exist, then future quantum sensors and detectors could tap into them. They might unlock ultra-secure communication, more powerful quantum computers, and entirely new ways to process information, using what was once thought to be nothing. And this isn't science fiction. Other real-world experiments support it. Weak measurements show we can extract data without fully collapsing a quantum system. Entanglement experiments suggest particles influence one another instantly across space. Even gravitational wave detect.
God, it's the level of bullshit that I but everybody, quantum this, quantum that. Oh. The sun is directly behind the moon during a solar eclipse. This means light is absolute. There are no photons, okay? It has been taken, honestly, it's unbelievable. Come on. Because usually, you know, so smack, light off, door down. I won't be long. It's a big truck. Could be a pebble thrown out the back of the tyre or a little rock that hits the window. Not so believable if it's just a little car. Oh, look, I'm gonna have to go for it when a car comes. Usually there's trucks all the time. Got that butterflies feeling there, a bit of, you sure you should be doing this? neighbour's fence. Oh. Ah. Well, I'm not going to hit a golf ball over the fence, am I? So it must have come from the neighbours, the other neighbours. I'm not going to smack a golf ball just over the fence, am I? I should leave that for now, though, tonight, I think. Can use that to our advantage. Paul, what do you think about a golf ball? Mm-mm. Over the fence. Now, if I'd have struck it, it had gone. Yeah. Well, this is the thing. When I can't practice in it, can I? See? And the dog only barked a couple of times, so maybe if the kids are out in the garden first, I can say, hey, there's a golf ball. He's a biggie, he's a jockey. Alright, so one quick read of a couple of little things that I think are, remember the 1975 that I was going to do? Well, $11 already? That. Oh, that was just, I was imagining 300 billionths of a second. So that would be the second. Imagine a second broken down into that. It's a second. That's 300 billionths of one, look. So, tick, tick. In that time, all of these, they've all done the whole up to 9999999 tick. Yeah. 300 billionths of a second. So, the one at the naval base, I take it would have been on 0, and so the other two, there's something like between them were something like 200 and something. 1971. So, Book of Astronomy, 1975. Actually, let me put you this. Now you've seen that. Imagine having those at the swimming galas. And he does win by 200 billionths of a second. Right, so a couple of bits. I've cut this down quite a lot because there were quite a few things. Yeah, let's go for this, seeing as we were just talking about that. When can we see the corona? When can we see the corona? All right. So, what does it say? The corona is very faint and cannot normally be seen because of the glare from the sun itself and the brightness of the surrounding sky. However, when a total eclipse of the sun occurs and the bright photosphere is hidden by the dark body of the moon, then the corona leaps into view, looking like a pearly halo round the sun. In fact, it is a layer of very thin gas. But do you know this? There's never there's a delay of 8 minutes and 20 seconds, but can you see what I'm saying? They never, ever, ever, ever mention it, which I think is a bit strange. Because you'd think it would be like common knowledge. It would be included in everything, wouldn't it? If there was a proper delay of 8 minutes and 20, there would be explanations for this, wouldn't there? But never, ever, ever. It is possible to see the inner corona at other times by using an instrument called the coronagraph, but this is only effective if used in very clear skies with a telescope thousands of meters up a mountain. Now, however, that men can go into space and so be free of the atmosphere, it is possible to make an artificial eclipse. You might do this by holding a coin of the right size in front of the sun. You see the corona at any time. For the rest of us though, an eclipse is our only chance. The appearance of the corona varies depending upon the sunspot cycle. Near sunspot maximum, it is more or less symmetrical around the sun, while near minimum, it tends to have a less regular shape. But still, not one single mention of photons travelling at 299,000. 792 kilometers per second. Now, we'll just do this one. What was that last? Why have I got 3? Oh, the black hole, yes. Right, Mars, okay. Can we breathe the air on Mars, right? Will men land on Mars this century? Don't forget, this is 1975, right? This is 1975. Right. Can we breathe air on Mars? The answer here is definitely no. The atmosphere of Mars is very thin indeed, and the pressure of the atmosphere is less than 1% of that on Earth. In fact, the Martian surface air is about as thin as our atmosphere at a height of 50 kilometers. The main gas is carbon dioxide. Other gases such as water vapor are present only in very small quantities. The atmosphere provides very little protection against radiation or meteorites, and it is unlikely that any earthly form of life could exist. If taken there, this does not exclude the possibility that some different form of life which might have formed on Mars may exist. That would be Martians, okay? Now, where are we? Nevertheless, strong winds do blow on Mars, and these can whip up tremendous dust storms, such as the one which obscured nearly all of the surface of the planet during the approach of Mariner 9 in 1971. What a bugger! Imagine that. I bet you the weather was perfect until they got there 7 months later, and then there was a big dust storm. Bugger. 1971. Same year as 300 billionths of a second out. Coincidence. It was very busy between 1969 and 1972, 1973. I do always think when I hear things like the atmosphere is as thin as 50 k's up down here and the dust storm, the ingenuity always springs to mind. I'm saying 60 plus flights. 60 plus flights flying in an atmosphere like 50 kilometers high from where I am right now. That is a hell of a feat, isn't it? Autonomous program it had used to land wherever it wanted to because of the delay. It's a big, anywhere between 5 and a quarter of an hour, 5 minutes and a quarter of an hour, give or take. So ingenuity just did its thing, landed where it wanted to. With change, autonomous program. Much like the Parker Solar Probe had an autonomous gear, like it would shift as it was orbiting the sun at a distance of 4.5 to 5 sun diameters. If its tail was poking out a little bit and it started to get a bit hot, it would autonomously correct itself. It's good programs. Give some time to focus on other things when you have autonomous spacecraft. Right. Will men land on Mars this century? Now, don't forget, this is 1975. In theory, it would certainly be possible. Sorry. To save fuel, it would be best to pick a year when Mars was going to make one of its closest approaches, and the next really suitable occasion would be 1986. Outline plans for such a mission exist. 1986. I joined the army in 1984. Didn't know they were thinking of going to Mars. Yes, I did. Everyone thought they were going to Mars in 1986. There was a window. Didn't happen. But no doubt it would have been close. 1986, 1996, 2006, 2016. Next year is 2026. So you see how it works. It's like a little thing that does the rounds, maybe once in a generation, and you'll believe it. See, they have us going for Mars. How close are they to the moon right now? Artemis, well, I'm there. It's gone quiet, isn't it? It'll bring back up. year 2, 3, 4, 5, and everybody will be, yeah, we're going back to the moon. It's 2070, we're going back to the moon. Wakey, wakey, peeps. I can't make one of those faces. And the next really suitable occasion would be 1986. Outline plans for such a mission exist. One possibility would be to send 9 men in 3 spacecraft, which would go into orbit around the planet before dispatching expeditions to the surface, in a similar way to the Apollo missions. However, there are many difficulties. For one thing, existing rockets are not powerful enough to take a direct path, and so the spacecraft would have to follow a long, curving path, taking perhaps 8 months to get there. They would then have to wait more than a year for a favourable opportunity to come home, taking 8 months for the return trip. Altogether, more than 2.5 years would be required. The main problem would be the cost, which would be truly colossal, and for this reason, a manned mission may not take place before the end of the century, which was a quarter of a century ago. The main reason they're not going to Mars in 1975, dinero, la plata, los dólares, money, too expensive. We're not going to Mars. The reason they won't be going to Mars is because of the money. That's 1975. I was gonna do a bit about a black hole, okay? Because it really is an amazing concept. Right? I'm not saying they don't exist. Why would I? One thing about that, though. That's why I wanted to read it, because of what it said right at the very end. It's not very long. It's only that. Just because these things happen ever so fast, so get rid of that now. Come on, off you go. Now, if you look about 1, 2, 3, 4 lines from the bottom, right? It says no one. See that? No one, 4 lines up. No one has yet discovered one for certain. And we cannot be sure that any exist. But it does seem possible. The massive stars may end their days by collapsing into black holes and disappearing forever from view. So they hadn't discovered any back then. 1975, 50 years ago. They've done their homework, haven't they? I would think, right. So this is the black hole. You've got the sun first, right? Sun. There it is. And then collapses into gravity and it forms a hole. So there's a hole here. A hole. So if you look all the way around it. How? What's it all about? There's a hole in, it's like space. Used to be a sun there. Not even photons can escape. Only if the dark photons can escape from a black hole. That could be it. Dark photons. So light gets sucked in and it sneaks back out as dark photons. All right, peeps, like I said, I have something that has taken out a lot of my focus at the moment, so I will still try to smash these things out properly. This is just a couple of little sprints, but something needs my attention, okay? But that does not mean the sun's light is not absolute, and it doesn't mean the Egyptians built the pyramids. So 100 billions, 300 billions of a second. Unbelievable. 1971.
Let's just listen. What we on? Oh, 24. We might as well get
Characters
it.
like LIGO use quantum light tricks to catch faint ripples in space-time. And understanding hidden photon modes could push those tools even further. Interestingly, dark photons already show up in cosmology. Some scientists believe they could even make up part of dark matter, unseen, undetectable, but shaping the universe. This model could be a bridge between quantum optics and cosmology, a unifying step towards something bigger. So where does that leave us? Not with a final answer, but with a better question. What else is out there that we simply done to know how to detect yet? Thanks for joining us in this deep dive into the dark photon theory, a bold reimagining of light and measurement that could change every...
Shut up, change everything. Everything's changed. Look, guys.
If you can't see by now, everything just keeps rolling over and rolling over, then you're never going to realize that. Nobody knows when it all started, where we came from, why we're here, or where we're going to go afterwards. I do. I keep coming back here, don't I? Honestly, guys, can't do. Some of these things, 1 million views. Is that 1 million people hopefully going, God, a load of bollocks. Not people going, oh, wow, dark photons. Where can I sign up?
Rubbish. Oh, later, peeps.